focus is going to be on opportunities for circular bioeconomy to improve the environmental sustainability of primary production. If you want to find out more about the MainstreamBio project, you can click on the QR code, and the project is focused on supporting rural areas across Europe in the mainstreaming of small-scale bio-based solutions. So today we've covered different topics. Today we're going to be focusing on sustainability aspects of the circular bioeconomy, with a particular focus on how this can impact on the primary sectors. So just to remind you, we're going to be recording the webinar, so people will be able to watch it back. And in terms of the series itself, so we're midway through the series. We've done 3 webinars to date. We've looked at technological aspects in relation to small-scale bio-based solutions, also looking at nutrient recycling practices. And today we're going to look more at the impact that these technologies can have for rural economies. So particularly today, focus on the environmental impacts. And next week, we're going to be looking at the business model opportunities that can come from these as well. If you want to register for some of the future webinars, please go to the MainstreamBio website, click on the QR code, and you can sign up for the remaining 2 webinars. Just a reminder to add questions to the chat, and we'll ask them to the speakers as we progress through the webinar. So we'll ask them at the end of the webinar. We'll have a number of talks, but you can add them into the chat and we'll take note of them and address them to the speakers at the end of the webinar. Okay, so today's webinar, as I said, is focused on opportunities for circular bioeconomy to improve the sustainability of primary production. From my own point of view, I'll give a bit of background, and then we'll have a number of speakers who'll help us to try and unpack this topic. We're going to hear from David Stiles from the University of Galway about leveraging sustainability for circular bioeconomy, from Katrin Jõgi from Fibenol on opportunities and innovative solutions in forest bioeconomy, and for Robert Harmoinen from Valio on developing a sustainable bioeconomy model for dairy cooperatives. And of course, then we'll get the chance to ask some questions to the speakers at the end of the webinar. So just in terms of background for today's webinar, I suppose to date we've talked a lot about the primary production sectors potentially being a driving force for developing a circular bioeconomy. A lot of the bioresources on which the bioeconomy is being built is dependent on the biomass that's coming from these primary sectors like agriculture, forestry, and the marine. So it's playing a pivotal role in terms of biomass supply and supply of residues that can come from these sectors. There are a lot of opportunities that can come from this, but it's worth also noting that these sectors themselves also face significant sustainability challenges. So, for example, according to the US Environmental Protection Agency, the net greenhouse gas emissions from agriculture, forestry, and other land use contributes to about 21% of total greenhouse gas emissions. And also, the global food system is a primary driver of biodiversity loss, which is another huge sustainability challenge that we face in today's world. And the primary sectors themselves, in response to this, are under increasing pressure to become more sustainable. So lots of targets that are being introduced across all sectors of the economy, but the primary sectors, such as agriculture, are themselves facing significant challenges. For example, a number of countries are implementing caps or reductions on greenhouse gas emissions to significantly reduce these by, for example, 2030 in a number of EU member states. So this is a huge challenge, and we talked about the potential previously of the circular bioeconomy, but the circular bioeconomy could potentially be a solution in helping primary sectors to address some of these challenges. So we talked about how the circular bioeconomy can take different types of biomass from these different primary sectors produce and create more efficient ways of producing products traditionally used, for example, for food, but also creating co-products through, for example, biorefineries to develop additional material and becoming more resource efficient with our primary materials. And then also using the different byproducts that can be generated from those sectors to manufacture new products that can potentially displace less sustainable products that are on the market at the moment. For example, displacement of fossil-based materials with bio-based materials. And also then looking downstream at the processes which produce, for example, residual streams, which could be used, for example, as nutrients, which could be supplied back to the agricultural soil or the forests. An example would be, for example, anaerobic digestion producing digestate as a co-product, which can be transferred back to the farm. So can the circular bioeconomy provide a solution? So the circular bioeconomy can enable improved availability of renewable energy based on agri-residues. For example, contributing to the Repower EU plan of 35 billion cubic meters of biomethane production per annum by 2030. And in that case, about a third of AD anaerobic digestion contribution to that biomethane target is actually expected to come from animal manures, which is a real nice example of circular economy in action. Promoting the recycling of nutrients, promoting more efficient practices on soil. So, for example, improved soil or land and biodiversity management. And so what we've seen here is that as the concept of the bioeconomy has evolved and matured, we focus less on just the technologies that can produce the different products, and we focus more on where it fits within a system and making sure that the overall system is sustainable. So if we introduce unsustainable feedstocks into a system, we can produce sustainable products, but it's not necessarily sustainable in the holistic sense. And so the definition of the bioeconomy has broadened out to include how we, for example, manage our land to produce feedstocks and avoiding some of the risks that can take place through, for example, expanding land use. And then, of course, enabling better use of agriculture, primary and secondary biomass to diversify markets and produce sustainable products. So there's, I think, a lot to consider from this opportunity. There's a lot of potential, and there are also some risks associated with this as well. And we need to consider, I think, not just the potential, but also the different trade-offs. So, for example, if we implement a particular bio-based technology or bio-based solution, maybe it could have an impact in terms of a positive impact in terms of greenhouse gas mitigation, but it may have environmental consequences in other areas such as soil or water pollution or other types of impact categories. So it's important to be able to measure, monitor, and model the impact of some of these changes. So to begin today's webinar, we're going to hear from Professor David Stiles. So David is Associate Professor in Agri-Sustainability at the University of Galway in Ireland, and he's Director of the Agriculture Science Bachelor of Science program. He leads and participates in a number of European and national research projects with a focus on measuring environmental sustainability via life cycle assessment of foresight modelling to identify pathways towards a climate neutral economy. He also sits on Ireland's carbon budget working group. He's expert advisory committee to the National Bioeconomy Forum and land use review and technical working group, and he's also a task lead on IEA Task 45. So I'm going to stop sharing and pass over to David.
Okay. Thanks very much, James, for the introduction, and thanks for the invitation to present here today. I'm just going to try and get the screen share to work and everything first. Hi, James. I'm not sure if you can.
We can hear you, but we can't see anything yet, Dave.
It's weird. It dropped out when I tried to connect the screen. It's behaving a little bit strange today.
Do you want to try once more? And if not, then maybe Gabby could potentially share the
slides. Yeah, is that working now? I've shown the screen, so I'm hoping you can see them.
Yes, we can see it.
Okay,
now.
excellent. Yeah. Okay, fingers crossed. That's all okay. Teams is acting a little bit strange, right? So thanks for the invitation to present here today. As James said, I'm working on a few projects looking at different aspects of the bioeconomy. So I suppose I'll just share a little bit of insight based on that. And some of that work is actually on a project Informed Bio, which James is leading, which is looking at a wide range of bio-based value chains in the economy. So I'll firstly present a rationale, if you like, for why we need to think to the future when we're thinking about the bioeconomy. We're thinking about investments that are going to be in place for some time, some decades. So we can't just think about what the situation will look like now. If we implement these things, we need to look into the future and to live within planetary boundaries. We'll consider why bio-based options are not always the better option. But there are many cases where bio-based options can leverage significant environmental benefits. So we'll also look at those examples and come to the point that actually how we implement the bioeconomy is really important. And then I'll simply present a synthesis of reflections. So I'll try and stick to time whilst doing all that. Firstly, we know that we're living well beyond our means globally. We're exceeding many of our planetary boundaries. And actually, food and the bioeconomy, food production and the wider bioeconomy is a major driver of many of these planetary boundary exceedances, especially regarding nutrient leakage, around land use, around ecosystem functions, and also in terms of climate change. So we have to be very careful, I guess, how we use our bio-based resources to not further contribute to the exceedances of these planetary boundaries. But it's also true that waste and overconsumption are a driver of about half of these burdens, certainly from a food production perspective. And when we think about competition between food and the bioeconomy, we also need to think where we need to go with the food system to make the food system more sustainable and the land that could be freed from doing that. So we could switch to alternative proteins, for example, to save massive areas of land and reduce emissions. We also have economic problems because farmers are basically running faster to stand still. Farmers are expected to produce more and more per hectare and per farm just to have a viable living. And in many cases, actually, their income is not viable. They're only supported by subsidies. So somehow that part of the system is broken, and we need to fix that part of the system as well as addressing the additional feedstock that we need to come in for other types of uses. So in a sense, there's an opportunity to reset and create a better system going forward. Production revenues are poorly distributed. Primary producers at the base of the value chain often receive the lowest returns from the products sold at the end, and that's contributing to this lack of sustainability. Meanwhile, we have greater expectations of how land is managed than the ecosystem services delivered by land. So that will have to change. And in terms of the business model of retailers, then retailers are only seen to be successful if they sell more every year. And we can't do that indefinitely. So there are some fundamental questions about the business models that we use that we need to address if we want to implement a sustainable bioeconomy. But a primary point here is that we need to live within these absolute planetary boundaries, and that's very important when we think about how we design bioeconomy solutions going forward. And it does require this paradigm shift in thinking. So up to now, we've been acutely focused on reducing greenhouse gas emission intensity, which has been very important. How do we reduce the carbon footprint or the nutrient footprint or energy footprint of a product? And that's extremely important. We can't take our eye off the efficiency ball, but efficiency is not enough. Efficiency, producing a lot of stuff very efficiently, doesn't necessarily mean you're living within your means, within your planetary boundaries. And that's where we need to think a bit more bigger scale, if you like, about how these systems are implemented in the wider context. Do they fit within a climate neutral circular economy? And that's where this idea of future gazing comes in. So again, it's coming back to this point. We can't just look at individual systems in isolation and look at relative efficiency. We need to think, how will this system function? How will this bioeconomy innovation or deployment function in the future sustainable economy? What's its role? How does it fit alongside all the other things that are going to change in the economy? Because everything needs to change to become sustainable. So we can't just take one piece of the economy, switch from a fossil-based to a bio-based resource, evaluate what it looks like and think the job's done. We need to think ahead. Will those bio-based resources still be used in 20 years' time? Will we still need that substitution in 20 years' time? Those are the kind of things we need to think about, and that's why we need to engage very much with future scenarios, not current scenarios of deployment. And this is where things such as strategic foresight becomes important, to kind of imagine these alternative futures of different land systems, different food-based systems, and where the bioeconomy fits within those systems. So it's challenging because we've got lots of options and everything is changing, and we have a lot of improvements in other sectors of the economy which are being made without bio-based inputs. So we have electrification of transport, for example, which can massively drive down emissions. We've got wind electricity, solar PV electricity becoming much cheaper, hydropower. We've got lots of options to decarbonize and to become more circular without using bio in certain parts of the economy. And we could recycle plastics much better in continuous loops. So there are ways that we could become much more sustainable without the bio-based inputs. But equally, there are parts of the economy we'll see later where the bio-based inputs have a unique contribution to make, and that's not replaceable by alternative approaches. And that's where we really need to focus the efforts to drive a sustainable bioeconomy that contributes in the best way possible to a future circular and climate neutral economy. But it's not easy because we have all these choices and we need to think, well, choices will need to be made. So that's probably a policy question, but we also need to imagine a little bit into the future. Where are some of these trends going, to identify where bio-based options have the best potential to contribute most? So as a couple of examples where bio-based is not necessarily better, we've got a first example of a recent study looking at edible cups. And this was a project funded by the Environmental Protection Agency in Ireland that specifically wants to look at edible packaging. So we've got these cups made of wafers, and the idea is that we can help to address the problem of littering and huge use of single-use cups. We use billions of single-use cups globally every year, and in Ireland alone, I think it's hundreds of millions of single-use cups. It's huge quantities being used every year. So the idea is that you can make a cup out of wafer that is able to contain the coffee. You can eat the cup after you've drunk the coffee, and there's no litter, there's no waste. When we did the life cycle assessment, though, we found that the edible cup actually had a comparable, slightly higher even carbon footprint compared with many of the other cup options. We had cups made out of PLA as well, bio-based plastic. We had a paper cup, polystyrene cup, which had quite a high impact, and then we had reusable cups. But here we see that the reusable cups are by far the best option. So reusing cups is a much better option than switching to a bio-based edible cup here. And one of the big drivers potentially was land use change from the cocoa production if you put chocolate in some of these cups to flavour them. So that's an example of where bio-based is not always the best. But on the other hand, it does depend quite a lot on the deployment model, because if people really do eat that cup after they use it, which is not always the case, and if they do not then eat a snack, another snack such as a chocolate cookie, chocolate biscuit, because they've eaten that cup, then you are leveraging big environmental advantage, because you're effectively not resulting in any net burden of producing that cup because you're replacing a similar edible material. So again, it comes very much back to how these things are deployed, but simply switching from plastic or paper cups to edible cups is not necessarily a panacea, because in many cases people might not eat the cup and it might still be discarded, and you've still got the impact associated with producing that cup with high input materials such as the wheat flour and the cocoa and the fat, the butter and everything. Another example is some types of anaerobic digestion. If we're just using maize biogas, for example, we can look at the total primary energy replaced per hectare when we consider the displacement of grid electricity with that electricity from combined heat and power. If we're only using the electricity, we end up with about 32 megawatt hours of primary energy displacement per hectare of land used. If we're actually able to use some of the heat electricity from the heat output from the CHP, we can displace up to 50 megawatt hours per hectare per year of primary energy. But those figures are pretty paltry when we compare what we can generate with wind turbines or solar PV panels per hectare of land occupied by those technologies, which is 100-fold greater. So in terms of absolute land use efficiency, using maize to feed into anaerobic digesters is not an efficient use of land from an energy perspective, nor is it from a greenhouse gas mitigation perspective. The GHG avoidance through fossil electricity and heat is not particularly strong. If we cause indirect land use change, then we completely outweigh any benefits, so we end up with net emissions overall from that switch to maize biogas. Miscanthus heating performs a bit better because we get high yields of miscanthus. We've got more carbon uptake into the soils under miscanthus because it's a perennial crop, so it tends to generate some modest greenhouse gas mitigation. But clearly, just using bioenergy for just using biomass for bioenergy generation is not in itself a panacea, and it can be very inefficient. So we have to be very careful how we do that. So that's another example of bio-based not always being a better option. But if we think a little bit more broadly in the landscape, there might be places in that landscape where the bio-based feedstocks, where they're different. So in the case of maize, it's more challenging because it's a food-based product. But if we're able to drive demand for alternative feedstock production in the landscape, such as willow or trees planted in buffer strips along watercourses, for example, we might be able to generate some positive ecosystem service benefits. So although our energy output per hectare of land might not be particularly high, by stacking up multiple benefits, multifunctionality from that land use, we could justify, it might become an efficient and attractive option to deploy that bio-based feedstock production for bioenergy within the landscape. Because we can improve soil quality, we can mop up nutrients, and we can provide shelter belts and habitats with certain types of feedstock, in particular fast-growing trees, willow, etc. And this is something that was looked at in the paper by England et al. In 2020, what they called strategic perennialization, trying to distribute these perennial crops, which could be used for bioenergy or other purposes, through the landscape in Europe. And they tried to look at the benefits that you could achieve in terms of nitrogen emissions to water, greenhouse gas emissions, reducing the dominance of arable crops in certain landscapes. So if we think carefully about how we implement bio-based feedstocks for bioenergy, it can be a useful strategy into the future. We also know that we've got to really dramatically change our landscape to achieve our net zero targets. And this is acutely the case in Ireland because we have very high emissions from agriculture. We also have net emissions from our land sector because of lots of drained organic soils and a very low recent afforestation rate reflected in poor greenhouse gas dynamics of our forest sector. So from work that we've done recently, we've seen that we really need to massively expand our forest area in Ireland, at least double it, to get to any kind of definition of climate neutrality whilst maintaining any kind of significant output from the bovine sector producing milk and beef, which Ireland exports to the rest of the world. And it's simply not possible from what we found to maintain the current levels of milk and beef production. We could prioritise one or the other. Milk is more profitable, be entirely possible to maintain current milk production, but we would need to still plant large areas. We need to spare large areas of land from current less efficient beef production and plant some of that land with trees to take up CO2 to balance off the emissions from the agricultural sector. So we need this big land use change to happen to get to net zero targets, and there's an opportunity there for bio-based feedstocks to provide some of that carbon sequestration and those alternative incomes to that land use that we do need to diversify. So potentially bio-based changes could leverage net zero in the wider economy. And of course, many of the bio-based, although numerous bio-based value chains where we can produce alternative proteins, and those alternative proteins can replace animal-based proteins, which take massive areas of land to produce, result in huge losses of nutrients to the environment, and result in very large greenhouse gas emissions. So there's a real potential to embed alternative protein production into bio-based value chains and maybe use side streams for other things. Could be animal feed, but it could also be bioenergy and other biomaterials. And that way we can massively leverage land sparing and greenhouse gas emission saving. We also need carbon dioxide removal to work in order to achieve a long-term climate neutral economy. And this is just an example of the long-term mitigation we can achieve with commercial afforestation, not just with the trees themselves, which of course become harvested, but with the harvested wood product carbon storage, which accumulates through time, with fossil fuel offsets, with concrete offsets. Even if we decarbonize, we'll still have some fossil emissions into the future, which can be offset with the bioenergy coming from forests. Concrete is very difficult to decarbonize. We can replace a lot of concrete in buildings. And finally, later this century, we expect carbon capture technology to work and keep that carbon from the combusted biomass at the end of its life locked away very long term. And that's where a bio-based option can really contribute long-term negative emissions, which is something we can't do with other options such as wind electricity and solar PV. So that's a real example of something very beneficial from bio-based options. Now I know I'm getting close to the time limits. So I think something perhaps just to finish off on some other work, we looked at bioplastic production to replace plastic packaging. Now that again had a higher footprint than the conventional plastic packaging, but it could deliver benefits if it meant that consumers can change their behavior because of the bio-based packaging. So because your lettuce that's gone past its sell-by date in the fridge is in bio-based packaging, you could throw that whole packaging potentially into your compost bin. That could then go to better treatments such as anaerobic digestion or composting. So in effect, if that change to bio-based packaging helps to manage the food waste better, it could deliver advantages versus conventional packaging, not because it has lower footprint to produce, because it could help behavior change. So that's one way that bio-based can be helpful. And coming to anaerobic digestion, we see it's not very efficient in terms of energy generation, but it's a core technology for transforming feedstocks into other chemicals, platform chemicals, which could be very beneficial for the bioeconomy. So if we treat anaerobic digestion as a technology to leverage wider, more multifunctional value chains, that could be beneficial. It's not an energy generating technology. That's a side stream that's important, but shouldn't be the main function. The main function is avoiding emissions from waste management and producing high value compounds. So we know we're going to have to keep producing carbon in a future climate neutral economy. That carbon probably should be bio-based to be sustainable. So there's definitely a need for bio-based options there. However, just switching fossil carbon for biogenic carbon is not sustainable because we don't have enough bio-based feedstocks to do that. And we also need to be careful that consumer behavior as well as technology determines the net benefit we get from some of these changes. Current land use is unsustainable, and switching to bio-based feedstocks could help to leverage much more sustainable land use configurations into the future. And we need these long-term emission sinks to achieve climate neutrality. And that's where the bio-based economy with cascading value chains ultimately feeding into carbon capture and storage offer this unique pathway to really economically valuably contribute to negative emissions in a way that we really need into the future. So I hope I haven't gone too far over time, and thanks very much for your attention.
Thanks, Dave. Really insightful presentation, and I think highlighting on one hand the importance of the primary production sectors and land management in the drive towards net zero, and the possibilities of the bioeconomy, but then the possibilities are really linked to the actual scenarios. So, you know, land use change, how these solutions are actually implemented, how the products are used, and so on. So it's not black and white. And as you said, I think it said bio is not necessarily best. It has to be kind of case by case. So thanks for that. If you have any questions for Dave, please put them in the chat and we'll get to them at the end of the webinar. So our next speaker is Katrin Jõgi. So Katrin is Sustainability Manager in Fibenol, based in Estonia, and Fibenol are the lead partner on the CBJU Sweetwoods flagship project. So aside from being Sustainability Manager, she's also one of the EU Bioeconomy Youth Ambassadors. And if you've been to any of the recent EU conferences in Brussels, you'll see the role of the youth ambassadors, young people who are active in the bioeconomy, helping to raise awareness and lead by example in relation to sustainable and circular bioeconomy. So over to you, Katrin.
Yes, I hope you can see my slides already. Yes?
Yes, we can see them fine. Thanks.
Great. Yeah. So greetings from cloudy Estonia. Thank you for the kind introduction. I'm Katrin, a sustainability manager in Fibenol, youth ambassador also, as mentioned, and I'm happy to share Fibenol's story and the innovation that we bring into the forest bioeconomy. So we operate a novel biorefinery in central Estonia, the one you can see on the slide here. For those who don't know, forestry and wood processing industry is very important in Estonia because more than 50% of our land is covered with forest, and it's a huge contributor to our economy. But as you may know, the forestry and wood processing industry generates huge amounts of side streams like bark, sawdust, wood flakes that are traditionally used only for energy production. And this is where the concept of Fibenol was born, to find alternative ways to valorize wood. So we managed to find the technology. We managed to get funded by the Sweetwood project. And fast forward to 2023, when we finished the construction, and now we are finishing up the ramping up phase and reaching full production capacity. And now we are already looking into building our first industrial plant, which would be around 7 to 10 times bigger than the one that we already have in Estonia. I already mentioned that the forestry and wood processing industry generates huge amounts of side streams. I have an example of a birch tree here. So around 50% of birch goes into plywood industry. This is the down part, and it is considered the good and most valuable part of the tree. But as you know, trees are in the shape of cylinder, and usually to produce plywood or construction materials or furniture, you need to shave down quite a lot of this woody biomass. And these are, for example, the residues that we can use. The middle part of the wood is considered already the low quality part because of the tree branches, and it is used in paper and pulp industry. But I would like to highlight here that the pulp and paper industry mostly valorizes only one component of wood, which is cellulose. But I will have a more detailed slide on that also coming up. And the upper part of the tree is usually used only for energy production. And it is estimated that only around 40% of wood ends up in the long carbon storage products. But luckily, with our technology, we can bring this number higher. I mentioned before that the pulp and paper industry focuses mostly on one component of wood, which is cellulose. But wood consists of 3 components. We have lignin, we have hemicellulose, and we have cellulose. And our aim in Fibenol is to valorize all these 3 components. And in our case, we can say that up to 90% of woody biomass could end up in value-added, long-lived products. Fractionating wood may sound easy, but it's actually quite difficult to do. There are different technologies available on the market. We operate the sunburst pretreatment technology. We are the only ones using that. It is extrusion-based. We combine temperature, pressure, mechanical force, and a little bit of dilute acid in this extruder to deconstruct solid wood in the form of flake wood or sawdust, for example, into this chocolate mousse type of mass. And from this mass, it's actually quite easy to separate the components of wood, meaning cellulose, lignin, and hemicellulose. To somehow summarize what I already said on previous slides, the raw material part, the low quality wood and wood residues from different forestry and wood processing industry steps, we can use that. We have the fractionation part in our factory. it is important to highlight that usually forestry and wood processing industry, not forestry, it's forestry itself, but wood processing industry is associated with high water use. And our aim is to reuse up to 95% of the process water. We have a really high-tech wastewater treatment plant to do that, and we run only on renewable energy. And we get our products. Our lignin is trademarked as Lignova. We have cellulose in the form of specialty cellulose, or if we hydrolyze it, we have C6 sugars. If you break down cellulose, you get basically glucose. And hemicellulose part is in the format of solubilized C5 sugars. So we have basically 3 different product groups: lignin, cellulosic sugars, and specialty celluloses. Cool. Yes, we have the components of wood. What else? We like to say that anything you can make out of oil or naphtha, you can make out of wood. Some of the things may not make sense, but when it comes to bioeconomy concepts, there are a lot of potential to replace oil-based products with woody biomass-based ones. For example, when it comes to our lignin, we have quite an advanced team working on developing different types of biocomposites. Lignin could replace phenol, formaldehyde-based resins and adhesives. Lignin has natural UV protecting properties, so it could be used in cosmetics and, for example, sunscreens. Lignosulfonates are already used in feed, and our lignin is also being tested right now, and of course, pharmaceutical applications. When it comes to our sugars, it's quite fascinating, the world of microorganisms. You may know that bacteria can also bacteria or yeast could also produce almost anything, but they need food to do that, usually in the form of sugars. So our sugars could be a substrate for different types of fermentation processes. We have partners producing different types of surfactants and detergents. Of course, ethanol production, it was already mentioned in the previous presentation about alternative proteins. Also, a lot of potential there. We already have a few partners working on producing casein, for example, out of our sugars. Different types of materials, for example, PLA could be produced from our sugars, and of course, different types of novel foods. When it comes to our specialty cellulose, we like to call it as microcrystalline cellulose, MCC. It could be used as an additive in paper and packaging industry, of course, pharmaceuticals. If you don't know, then if you take ibuprofen, usually the main part of the pill consists of MCC, so it's basically the same thing. Also, the cosmetics industry, different types of paints and adhesives again. And just to highlight here a nice use case. So lignin could replace bitumen in asphalt making. This photo is taken last year in June next to our demo plant in Imavere. So we already have practical knowledge on using our lignin as a replacement for bitumen. The parking lots and roads surrounding our factory in Estonia is already put down with lignobitumen. Lignin has a lot of potential. Of course, it is not the highest value application in the sense when we compare cosmetics or adhesives or some other specialty chemicals, but it is a great stepping point into or getting our products on the market. So when combining lignin in asphalt making with bitumen, it is possible to lower the carbon footprint of the roads. It is really beneficial, especially when it comes to Estonia, to use local resources. It would also support the resource independence. At the moment, as far as I know, the Estonian asphalt producers need to import their bitumen from South America and from other regions really far away. And of course, using lignin in asphalt making would keep the biogenic carbon also sequestrated for quite a long time. Of course, it depends highly on the asphalt production practices, but in Estonia, usually, for example, if the asphalt is broken down or something happens, it would be collected and used as a resurface material in lower layers. So it would be still used as in the same application for a really long time, so more than 100 years. So it would be a great carbon sink, and it could contribute also to national greenhouse gas emissions inventories in a positive way. And of course, like the lignin is not the silver bullet to make the asphalt production industry more sustainable. Of course, other things could also be considered. For example, when using biofuels in the asphalt making, then and combined with lignin substitution, it's quite easy to produce carbon neutral roads. Just an example of how wood processing industry residue could be turned into asphalt production carbon sink in the future. And yeah, this is it from my side. I think I managed to cut back some of the time that was used before.
Thanks, Katrin. I really enjoyed your presentation, and thanks for telling us about the work of Fibenol and the Sweetwoods project. And I think there was a really nice link between your presentation and David's presentation, where you looked at some of the kind of difficult to decarbonize areas and opportunities for carbon sequestration. And it's clear, I think, that the forest bioeconomy and increasing possibly afforestation as well will, in terms of land use, is going to be one of the key strategies for climate neutrality. So thanks very much. And if you have any questions for Katrin, please add them to the chat. So our final speaker, and we've talked a lot about, I suppose, we're moving from the forest bioeconomy to the agri-bioeconomy, and we mentioned in the introduction that the agriculture sector is under a lot of pressure in terms of the food sector is in a lot of pressure to decarbonize. One of the companies who's making a leading role in terms of trying to address some of those challenges is Valio from Finland. So Robert Harmoinen works as development manager at Valio, who are a Finnish dairy co-op, and within their climate team. His main role is to involve dairy farms with biogas production and increase the share of renewable use and production on Valio's dairy farms. He also takes part in implementing several other climate actions into Finnish agriculture sector. So with boots on the ground and looking to find out what's happening in Finland, over to you, Robert.
Thanks, James. I hope now you can
we can see it now.
Yeah. So hello, everybody. Glad to be here. So I work at Finnish dairy house Valio. So I would like to tell a few words about Valio before I go to our climate program. So Valio is a Finnish dairy house. We are owned by our dairy farmers, and we are the biggest food company in Finland, and we are the biggest food exporter here in Finland. And we are known for our high quality products and sustainability. I think we have been chosen to be the most sustainable brand in Finland for almost seven consecutive years already. There has been a few years between, but we have been always in the top chart when it comes to sustainability here in Finland. We have 14 factories. We have 12 dairy factories here in Finland and two in Estonia. And we are exporting to approximately 60 countries. So we are quite exports-oriented company, and we are founded in 1905, and the funny thing is that Valio actually has won a Nobel Prize for this silage preservation technology. AI Virtanen who was at Valio got a Nobel Prize. So yeah, Valio is 100% owned by cooperatives that are owned by the dairy farmers that are approximately 3,400. And I actually come from one of those dairy farms myself, so I'm really proud to say that basically I'm still working on my own home farm. So let's go to Valio's climate program. So we have the goal to reach climate neutral milk chain by 2035. And how we are going to do that is we are going to mitigate our emissions in scope 1, scope 2, scope 3. And we are also going to make some carbon removals from the atmosphere. So we are going to sequestrate carbon into the soil, and we are also interested in adopting technologies where we capture CO2 from our production plants and we store it or we utilize it somehow. And Valio's climate program was kicked off in 2018. So at least in Finland, we were pretty much one of the first companies to have ambitious climate program, and we are really working on the goal to achieve the target. How we are following the progress of the climate work is that we have a calculator for the farms. The farms are calculating annually their climate impact. So they basically put the amount of resources that they are using in their production, and then they and how they do the milk production, and then they also insert the amount of products that they are producing. So they are calculating carbon footprint, and that is really valuable for us because we know what is our climate impact in dairy and how we are moving on with our target. The calculator is really high quality calculator, and it has been certified by Carbon Trust. So it is not just some calculator that we are using to get good PR, but it's really tested and it's certified. So yeah. Not all the farms are calculating currently, approximately 2,000 calculations this year, and we have a target to have all those 3,400 farms calculating by the end of this year. So we still have quite a long road to go, but we believe that we are getting there. We have this so-called sustainability bonus for our dairy farms. So whenever Valio farms are implementing certain climate actions, we are giving them some bonus within the price of milk. So the amount of money that we are paying the farms is increased when they are implementing these certain climate actions. And having these calculations done is one of those actions that we are giving the bonus for. So the idea is that we can't act correctly if we don't know what comprises the carbon footprint of milk. So this is really valuable. This has been valuable and it will be valuable in the future as well. About Valio's climate program, so we are calculating our emissions to 2019. So that is our baseline year of emissions, and that year our emissions were approximately 3 million tons of CO2 equivalent that year. And when you compare to Finland's total emissions, it's about 50 million tons. So you can say that it's quite a lot, but like I said, we are the biggest food company in Finland, and we are feeding quite many people. So I think that is pretty much quite understandable. So the goal is including emission reductions, so less emissions, for example in fossil energy, but we are also including carbon removals such as carbon sequestration in the mineral soils, and these new technologies are really interesting for us as well. We also follow the progress. You can see in this picture that we have already gotten some emission reductions, so 17% compared to 2019. That is really good. And we are also making an annual forecast about how our emissions will develop. So we know these certain climate actions. We know their potential, what is the emission reduction per action, and how we are predicting that the farmers will take them in use. So we can forecast. Unfortunately, we have to say that right now it seems like we are not going to reach the target of 2035 carbon neutrality. We are still missing 0.7 million tons of CO2 equivalent. And that is something that we're working on. We're trying to identify some new emission reduction technologies that could close the gap of 0.7 million tons of CO2 equivalent. But I think anyways, the progress is really good and looks like we're going to get quite a lot of things done. So I would like to talk to you about biogas at Valio because we are really interested in biogas production because that is something that increases the profitability of dairy farming or farming in general. So basically, when you are producing biogas out of agricultural feedstocks, you are actually changing the form of, for example, nitrogen fertilizer nutrient into form where the farmer can utilize the nitrogen more efficiently. So they basically need less fossil chemical fertilizers. So the climate impact is there, but there's also the economic impact, the beneficial economic impact. Then well, there are several pluses for the farmers, but I'm not going to go into so deep into that. Then we are also interested at Valio. We are interested in using the biomethane, our own produced biomethane in our own logistics because it's cheaper than fossils. So diesel, it's renewable and it's also domestic. So it's energy that is coming from our farms and we can use it for milk transports and product distribution and so on. So we have the keys to increase the consumption of biogas while we have the keys to increase the production of biogas. So we are pretty in quite a happy spot here. Biogas production from agricultural biomasses can also have quite a significant climate impact. So on farm level, or in total, you can mitigate carbon footprint of milk by 25%. And out of that, 1/5 is coming from the dairy farm. So manure storage emissions go down and you need less chemical fossil fertilizers. And then you are also allowing emission reductions on the transport sector. So this is something that the farm is doing, allowing emission reductions on some other sectors, so transports, for example. And manure-based biogas production is currently quite small in Finland, so we have quite a lot of work to do on this one still. I know I'm a little bit over time, but I want to tell you how we're going to do it. So we are now planning for the biggest biogas plant network in Finland, in Upper Savo. The farms would basically participate as feedstock suppliers. So Valio and ST1, energy company ST1, we have a joint venture called Suomen Lantakaasu Oy, basically meaning Finnish Manure Gas Ltd. And we are collecting the feedstocks from the farms. We're producing biomethane, and ST1, the energy company, takes care of the distribution of the biomethane. It's a network of 4 biogas plants. I will show you a picture in the next slide. And it should be operational in 2026. And what is nice about this plan is that farms don't need to have their own biogas plants because own biogas plants are really expensive and there's a risk, business risk. So in this model, farms need smaller investments, but so therefore a higher amount of farms would most likely participate, meaning that we can have a big emission impact and also profitability impact on Finnish dairy farms. And what is nice about this is that the local farmers are really interested in taking part, and we are actually signing contracts with them currently for them to take part in the production. The last slide is about how the biogas production of Valio and ST1 would take place. So we have 4 biogas plants now planned in Upper-Savo, Upper-Savo. In the biggest biogas plant there, we would have biogas liquefaction, and then the 3 smaller biogas plants would feed the central biogas plant with CBG, and we would liquefy all of the biogas so that we can get it for heavy transports use. Sorry for going over time, but yeah, thank you for your interest, everyone.
Thanks, Robert. Really nice insight into the work of Valio in terms of not just using biogas on the farms, but also within the milk fleet, and also highlighting the importance of measuring from a farm perspective the sustainability impact of farms as a means to try to look for mitigation opportunities, and then to motivate the farmers as well towards that. And having 2,000 farmers already subscribed and operating this calculator is an incredible achievement. So if you've got any questions for Robert, put them in the chat. I would invite David and Katrin as well as Robert to keep your cameras on as we go into the Q&A part. And Debbie has put a questionnaire into the chat, so if you do get a chance to complete our questionnaire, we would be grateful. You can also access the questionnaire using the QR code on the screen now. So we're still waiting for some questions to come in, but to begin with, I might start with David. So we talked a lot about agriculture and forestry. We haven't touched on the sort of marine-based bioeconomy. We did look at this a little bit during last week's webinar to look at the possibilities for marine-based products. So how do you think that the marine bioeconomy can potentially help in the kind of mitigation efforts around maybe reducing land use, and what would be the possibilities and potential there?
Yeah, that's a good question. Thanks, James. I think obviously there's much, you're taking out the land pressure, and that can be very important. I suppose there's different types of algae and seaweeds that could be used, and they can be used in various ways. I mean, I think in general, it seems to be an economic issue. How do we do this economically? I think if it can be done economically, then there's lots of positives. Could even be benefits in terms of harvesting nutrients which are lost to coastal waters from runoff, and in a way you're almost cleaning up kind of ecosystems by taking out surplus nutrients. So there's lots of benefits. Certainly mussel farming is kind of proposed that way as a very sustainable protein source. So I think definitely lots of benefits if we can get it to work, and I guess it's a question of business models and economics to leverage that benefit.
Okay, thanks, Dave. Katrin, coming to you. So how can bio-based industries and startups make the correct choices on which value chains or products will have a positive sustainability contribution? And we're going back to the trade-off question here, and sometimes it's difficult to know what to scale. So what would you do as kind of an early stage startup looking into these possibilities?
Yeah, I think it's a great question, and there is no right answer to it. But speaking from our experience, it's quite difficult actually to get new products on the market, even if there is like a really good environmental benefits and low CO2 footprint and so on, because at the moment our economic models are still highly dependent on the price component. So if it's not price competitive, then there is like really low interest. So the product segments to target are more like the green premium, really specific types of products. But in general, I've seen already quite a big shift to replace, for example, when it comes to materials industry and chemicals industry that still use a lot of food and feed crops for that types of applications. I've seen a shift there, so there is more interest in using not food and feed crops. But yeah, there is no right answer to that. It's rather difficult, I would say.
Okay, thanks, Katrin. Robert, just wondering, in terms of your anaerobic digestion, is it solely manure, or are you looking at co-digestion for the different farms, or what model do you use?
Yeah, good question, and I forgot to tell you in my presentation, but it's co-digestion, so manure, field biomasses, so waste grass, for example, and then food production side streams. So, for example, from Valio production facilities, we take some leftover or bad waste streams, and we put them in the biogas plant. We produce some transports fuel, and we return the nutrients to the farm. So that is, I would say, one of the best forms of circular economy.
And in terms of your 2035 targets, how significant a contribution do you see that scaling up process making towards the contribution, the overall goal?
Yeah. So we are expecting that approximately 11% total emission reduction can be achieved with our biogas production. So on a single farm, the emission impact can be even bigger, but as all the farms are most likely not participating in our biogas production, we are not going to get there. But now that I know our joint ventures plans to invest in biogas production, we are calculating that approximately 11% emission reduction could be achieved.
Okay, great. Just a final question to you, just in terms of the sustainability bonus that you pay the farmers, that's a big commitment, obviously, from the co-op, incentivizing farmers to do this. Do you feel like it should always come from kind of internally or within the company, or do you feel like the governments at the member state level also need to make a contribution to farmers who will have to make more sustainability choices, maybe not just in dairy, but across different sectors?
That is actually a really good question. And first of all, I think that too often, I think climate friendly and productivity are considered two different things, even though actually they are quite often the same thing. So if you are, for example, if you're productive, you can also be really climate friendly. So that is not they are not different things, basically. But so I think we have to spread information for the farms, and so how those actions can be actually quite profitable. And also for Valio, for example, it's a job that we are looking into this climate action so that we try to find models that actually can boost the profitability of the farms. So, for example, with this biogas production, it's not like there is a model already, but we had to make it so that the farms are really getting something out of it. So that is actually a good example of emission reduction method that can be boosting the economy of the farms. So they're really interested, and we have to do the same thinking for all the climate actions. And the question whether who is going to pay for all the costs that will come. So I think in the long run, it should be the client. So who is buying the products, they should pay, because they're the ones who are consuming, and they're the ones who are requiring these actions to be done. But for us at Valio, I think it's job to find ways how to get clients to pay for these actions. But also I think that is not enough. So we need regulation, but I don't mean by regulation, I don't mean that there should be sticks. I think agriculture is a sector where you need especially carrots for these things to really be implemented.
Okay, thanks, Robert. Dave, coming back to you. So you've focused quite a bit on land use change. I'm not sure. Are you there? Oh, Dave might
yeah,
have
James,
dropped.
I'm here. Yeah, it dropped
Oh,
out
you can
again
hear
for
us.
some
Okay.
reason.
Okay. So you talked a lot about land use change. So in terms of kind of scaling the bioeconomy and also scaling climate mitigation, you could go in a lot of different directions here, which could have positive or negative consequences. So I'm just wondering, what kind of trends do you see potentially happening across Europe over the next 20 years in terms of, you know, the 2050 targets with regards to land use?
Yeah. I mean, I guess Ireland's maybe a bit of an outlier in some ways because we have a very low forest cover. So for us, it makes a lot of sense to use trees as one of the main levers we have to increase carbon sequestration. I mean, I guess, Katrin, in Finland, you have very high forest cover already. You're starting from a high baseline, and maybe it's how you manage the forests that becomes important, and what you do with the downstream wood products. So, and then there are other parts of Europe, I suppose, like France, with big arable areas, and there's a lot of potential to sequester more carbon in soils, but that requires quite different management of those soils, and arable areas are where soil carbon is in a low baseline. Again, in Ireland, we have very high carbon stocks in soils, so the risk is more loss. We don't have much more opportunity to gain to offset emissions where you have a big risk of loss. So I think it's very context specific where you are, what you can do to achieve those carbon sinks that we need. And it's very, very different across different parts of Europe. So we just need to be mindful of that, but more importantly, we need to think long term. We need to think, how big a sink are we going to need long term to sustain climate neutrality after 2050, as well as getting there? And how do we manage land? But importantly, then, how do we manage biomass after we harvest it? And this is where the carbon sequestration technologies and cascading use of products, keeping that carbon locked away as long as possible, those are all really critical. So it's really the how we use the land to produce sustainable feedstocks, and then how we manage that biogenic carbon in the feedstocks long term. That's really critical for our climate neutral future, and it will be different, I guess, in different countries.
Thanks, Dave. And Katrin, slightly related question, just coming from your own perspective in the forest industry and the forest bioeconomy, the need for forests to serve as a carbon sink and at the same time to produce bio-based products to, you know, to defossil the economy and everything else. How do you find that balance in terms of how you manage your forest rotation and whatever in terms of achieving that sustainability target?
Yeah, great question. And I completely agree what David already said. But when it comes to Estonia, but not only Estonia, when it comes to countries that have a lot of forest, forest also has its life cycle in the sense of when it's young, it would take more carbon from the soil, and in the growing phase, it would absorb a lot of CO2 from the atmosphere, and older forests start to actually emit CO2 in the atmosphere. And of course, we cannot put the price on the ecosystems that come with forests, but when it comes to, well, we in Estonia, we also have a term for like a forest is ready to, we call it like the forest is ready in the sense that it's ready to be cut down and used in the construction industry or in the plywood industry. As David said, I think there's a lot of special approaches, and it highly depends on different countries, different regions, what makes sense. In our case, forestry is the main, or actually one of the only possibilities to have national carbon sinks. And forest has to be managed in a sustainable way. I think sustainable forest management practices are the key of having like a sustainable forest carbon resources and so on. I think it's a combination of forest owners forest industry and also the local governments and our country institutions that put somehow all this down into the most sustainable way in all the different areas, the economic part, the biodiversity part, and also the national goals of having the greenhouse gas emissions inventories in place. So it has to be managed in a really delicate way so that everyone would be happy. So yeah.
Okay, great. Thanks, Katrin. So I think that's all we have time for. My thanks again to Katrin, David, and Robert for really insightful and diverse presentations. I will just share this briefly before we go. So next week we have our 5th webinar coming up, which is focused on business model and social innovations for promoting bioeconomy development in rural and coastal regions. And today we shifted to Tuesday. We're back to Wednesday again next week. So you can join using this link or by visiting the MainstreamBio website. Just a reminder to please fill our questionnaire if you get a chance at the end of the webinar. Let us know what you think. The event will be recorded, so you'll be able to watch it afterwards as well. So thanks again to our speakers, and bye-bye.
Bye-bye. Thank you.
Bye-bye.
Thank you. Thanks, Dave. You're on mute.